Hello everyone. Today let's solve the problem 4 pairs. Right. So this was asked on educational code forces round 10. Right. So what the question states here, before going through the question, you can just go through the question. It is very easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem. So what the question states here, just give me a second, 1 second. Yeah. So what the question states here, we are given a permutation P of size n and m 4 pairs, right? So we are given a permutation P. We are given a permutation P of size n and m 4 pairs and m 4 pairs. This is nothing but size and this is nothing but pairs, 4 pairs. I'll just write FP here, right? FP here. So I hope this part is clear, man. We have been given a permutation P of size n and m 4 pairs. We need to count how many subarrays x comma y. We need to count how many subarrays, that is nothing but x comma y, do not contain both elements of any 4 pair. So we need to count how many subarrays x comma y do not contain both elements of any 4 pair. A subarray is valid if it contains both elements of at least one 4 pair regardless of their order. So this is very important. A subarray is invalid if it contains both elements of at least one 4 pair regardless of their order. So what we need to do, what is our main goal here? We have to print the total number of valid intervals. This one, x comma y. We need to print valid intervals x comma y that don't include any 4 pair. That don't include any 4 pair. It shouldn't include any 4 pair. That valid interval x comma y we need to print. Means we need to print out the number of total this one valid intervals. Just remember this one, right? We don't have to print the valid intervals. Instead we have to print the total number of valid intervals that don't include any 4 pair. So answer must be computed efficiently for the large n m up to 3 into 10 to the power of 5, right? So that's what they have given in the constraints. You can just go through the constraints, right? So you can just go through the constraints or the input output part. This one I'm speaking of, right? So here the time limit is 1 second and the memory limit per test case they have given 256 MB, right? 256 megabytes. This is fine. Most of the time we don't have to worry about the memory limit. So this will be sufficient. We just have to take care of the, in most of the times I'm speaking of, sometimes we do get MLE, but most of the times we have to take care of this one, TLE, right? Or the time limit basically. So again I'm going to read this loud. Just listen to this. We are given a permutation P of size n and m. This one, what do we call permutation P of size n and m 4 pairs, right? So we need to count how many subarrays x comma y do not contain both elements of any 4 pair, right? So we need to count how many subarrays x comma y do not contain both elements of any 4 pair. A subarray is invalid if it contains both elements of at least one 4 pair regardless of their order. So subarray will be invalid if it contains both elements of at least one 4 pair, right? So this, just keep this in mind. This sentence is very important. We have to print the total number of valid intervals, nothing but x comma y, that don't include any 4 pair. So answer must be computed efficiently for the large n comma m, nothing but up to 3 into 10 to the power of 5, up to 3 into 10 to the power of 5. This one I'm speaking of, up to 3 into 10 to the power of 5, right? So this is mentioned in the constraint. Basically you can just check that one, right? So let me delete this one entirely. So let me come here. So we have been given, let's come to the example part. We have been given 4 2 1 2 3 4, this one 3 2 2 and 4, right? So this 4 is nothing but n here, this 4 is nothing but n here, this 2 is nothing but this one m, this 2 is nothing but m. Means we have already discussed this one. We have been given a permutation P of size n and m pairs. So size is nothing but 4 here, size is nothing but 4, and m is nothing but 4 pairs is 2. 4 pairs we have here as 2. And P we have been given, P we have been given this one, permutation we have been given 1324. We have been given 1324. P we have been given 1324. 4 is size, 2 is nothing but m here, 4 pairs, right? So 3 2 and 2 4 we have here, right? And this one 3 comma 2 and 2 comma 4 is nothing but 4 pairs. So I'll just come here. So let me write this one, you'll get to know. 4 is nothing but n, size n, and permutation P consists of the size n and this one m 4 pairs. This is nothing but 2 4 pairs, right? So here we have 2 4 pairs. This is nothing but 3 comma 2 and 2 comma 4. These are the 4 pairs. I'll just write FP. We have 2. nothing but they have mentioned m is equal to 2 in the input itself. 4 is nothing but the size, permutation size, and this one permutation is nothing but 1 2 3 4 we have been given. This you can consider p, right? So the output then that we need to get here is 5. The output that we need to get here is 5. What we need to calculate? We need to calculate how many subarrays do not contain both elements of any 4 pair. Both elements of any 4 pair 3 2 2 4. How many such elements, how many subarrays how many subarrays that do not contain both elements of any 4 pair we need to calculate here, right? So we need to calculate that one. In this case it is 5. In this case it is 5, right? So same goes with example 2 as well. Same goes with example 2 as well. See, what shall we do now? Let's discuss the approach followed by the complexities, man. So I'll just consider the first example for considering the approach. What you have to do, just follow along with me, and just you can just I insist you to try out with the second input the same way that I that we go for the approach by making use of the example 1, right? The same thing you can try it out for the example 2 or the input 2 that they have mentioned in the question. Example 2 or the input 2 that they have mentioned in the example. You have to get the output 20 for the second one, and for the this one, what do we call, for the first one we have to get the output 5. First one we have to get the output 5. So I hope the question part and the input output part is completely clear, man. I hope the question part and input output part is completely clear. What shall we do? First let's discuss the approach followed by the complexities, and then let's write the code. Usually as usual, let's discuss the approach first. So here I have considered, sorry, just give me a second. So yeah, here I have considered the same first example that they have given in the question, right? So here n we have the size of the permutation we have n, nothing but n here we have is 4, and 2 is nothing but the this one 4 pairs, right? So this is nothing but m. The 4 pairs we have here is 3 2 and 2 4. This is nothing but the permutation p. The output that we need to get here is 5, right? So we will be making use of the 2 pointers along with the sliding window. Just keep this in mind. We'll be going with the 2 pointers with a sliding window. This is pure intervals based question, right? So this is pure intervals based question. So we will be making use of the 2 pointers along with the sliding window, or 2 pointer sliding window, right? So we have already solved many problems using the 2 pointers as well as the sliding window. We should be knowing how it works. I am not going to explain that one, right? So we should be knowing by this time. We have to know 2 pointers along with the sliding window approach. So what is it, how it works, right? Those kind of things that I'm speaking of. So here in this case we need to get the output 5, right? So let's move on with the step by step explanation. We have n equals 4, m equals to same. This one I have considered here 4 pairs, 3 to 4, nothing but here this one input part. This is nothing but the input part here. So first thing is we have to map values to the positions. We have to map values to the positions. We cannot convert p into positions to find where each number appears, right? So we cannot convert p into positions to find where each number appears. So what we are going to do, we will be mapping values to the positions. We will be mapping values to the positions. See here, value to index, this is 0 based, right? So first we have here 1 3 4 2. So this is the permutation we have, right? So we are considering 1 3 2 and 4, 1 3 2 and 4. So sorry, yeah, 1 3 2 and 4, right? So this is 0 index, it starts from 0. So yeah, this is written clearly here, this is 0 based indexing, right? So 1 is mapped to 0, 3 is mapped to 1, 2 is mapped to the value 2, and 4 is mapped, the value 4 is mapped to the key, this one 3, right? This one I'm speaking of, this is 0 index. Just keep this in mind. We are mapping the values to the position, so this is nothing but the position. So position, nothing but index, right? This is 0 based, this is 0 based indexing, right? So this involves 0 based indexing. So 1 we have mapped to 0, 3 we have mapped to 1, 2 we have mapped to 2, and 4 we have mapped to 3, right? So I hope this part is completely clear, man. So here we maintain position of value to the index. So we maintain, I have assigned position of value to the index, nothing but position of 1 0, position this one, see this one permutation value, position of 1, position of 3, position of 2, position of 4. This one is nothing but index 0 1 2 3, 0 based indexing, right? So we know this one. We are just maintaining the position of value, we are assigning that one to the index basically. So I hope this part is completely clear, man. I hope this part is completely clear. We will process 4 pairs to mark the block intervals. 4 pairs we have two 4 pairs here. We have two 4 pairs here. One is 3 comma 2 and another one is 4 comma 2. One is 3 comma 2 and another one is 4 comma 2. Let's consider the first one here. 4 pairs 3 comma 2, indices are 1 and 2. See here, 3 comma 2, 3 we have index at index 1, and 2 position of 2 we have at index 2, right? So indices here, where it went, so just give me a second. Yeah, indices are 1 and 2, means u equals 1, v equals 2. We'll be considering u equals 1 and v equals 2. So we cannot allow any interval ending at r equals 2 to start before l equals 2, as we are going with the this one, two pointer sliding window. This you have to know at any cost. By this time you have to know the two pointer sliding window approach, so arrays, all the basic things you have to know, right? So we have already come to the part we are solving the problems on this one, intervals and greedy, right? So this is going to be the last questions within the intervals, and the next two problems will be based on purely greedy approach, right? So you have to know this thing, what do you call, two pointer sliding window. We have solved problems on this one, stacks, queues, everything you have to know by this time, right? Because we are left with next, after this one, after solving this concept, we are left with only four this thing, what do we call, only four approaches basically. One is bit manipulation and math, and we are left with the last three, the main things, this one, segment tree, Fenwick tree, or the sparse table, that is one concept, and the last two is advanced graph and advanced dynamic programming. These four things will be left with basically after solving this one, intervals and greedy based questions, right? So at this point of time we have to know most of the things that we have solved earlier, so we have to be crystal clear about the topic that we have done till now, right? So let's move on with the other thing. So we cannot allow any interval ending at r equals 2, and we have to start before l equals 2 here. This is fine. So we have to update block of 2 equals max block of 2 u plus 1, max of 0 comma 2 is nothing but 2. We are considering just value here, man. Max block of 2 u plus 1, u we have, u and v we have 1 and 2, right? So this u is 1, v is 2. Indexing, if you remember here, this one we have mapped this one to u equals 1, v equals to 2, because indices we have 1 and 2, where we are considering the first four pair, 3 comma 2, 3 is present at 1, nothing but this is u, 2 is present at 2, index 2, nothing but v, right? U equals 1, 1 equals 2. So here in this case we will be updating the block to nothing but max block of 2 comma u plus 1, u plus 1, u we have 1, 1 plus 1 is nothing but 2. This will be 0, block of 0 consists of 0, block of 2 consists of 0, and we have this one, 1 plus 1, u is 1, 1 plus 1 leads to 2, 0 comma 2 is we are considering max of 0 comma 2, nothing but 2. Next we will be doing same thing, for the next pair. We have two 4 pairs, right? We have two 4 pairs here. You can just consider, see here in the input we have two 4 pairs. One is 3 comma 2 and another one is 4 comma 2. One is 3 comma 2 and another one is 4 comma 2. So we have 4 pairs, 4 comma 2. Indices are 3 and 2. So where we have 4 comma 2 we have, right? So indices we have this one, 3 indices we have 3 here. This one 4 comma 2 we have, right? We have this one 3 again 2, 3 again 2. So for 3 comma 2 indices are 1 comma 2, 1 comma 2, and for 4 comma 2 we have 3 comma 2, because 4 position of value is present at the index 3 and position of 2 is present at the index 2. So this is present at 3 comma 2, right? So here let me come to the page number 5. Just give me a second. Sometimes this doesn't work, man. Just give me a second. So here let me come here. Yeah, yeah, here we have indices 3 and 2. Now we have the idea, right, how we have got 3 and 2, right? Indices are 3 and 2 for the pair 4 comma 2. So now we will assign this one to u and v, nothing but here in this case this will be u and this will be v. Again we have done the same thing to the first pair as well. We have done the same thing to the first pair, 3 comma 2. So here u will be 2 and v will be 3, u will be 2. So we will be going in the ascending order. Sorry, this will be v and this will be u. The smallest value we will be assigning, always we will be assigning the smallest value to the 2 and the largest value to the v. Don't get confused here. So Sorry, so I got confused here. So this one we will be going with u will be 2 and v will be 3, right? So that's what we have done. So we will update block 3. This one will be max of block 3 comma u plus 1. U we have 2 this time, right? Again, block of 3, block of 2 remains 0. Block of everything remains 0 itself. We don't have the value. We'll be considering 0 itself. This will be 0 plus u we have 2. 2 plus 1 is nothing but 3. So this will be max of 0 comma 3, nothing but it will lead to 3 as well. It will lead to 3 as well. So here in this case max we have got 2 for the first 4 pair, and for this one max we have got 3. For the second pair we have got max pair equals 3. For the first pair 3 comma 2 we have got the max value 2, max value 2 itself, right? Yeah, max value 2 here, this one. And for the second pair 4 comma 2, just give me a second here, 4 comma 2 we have got the max 3. 4 comma 2 we have got the max 3, right? So final block array becomes now 0 0 2 3. 0 0 2 3 block, the value we have is 0 0 and the max we have got is 2 and 3. The first pair consists of the max value 2 and the second pair consists of the max value 3. So this will be 0 comma 0 comma 2 comma 3. So because both the block values, block of 3 and block of 4, we have block of 2 and block of 3, I guess here. Yeah, this one is block of 3, this one is block of 2. Block of 2 and block of 3, both the values are 0 0. We are considering 0 0 and 2 3. 2 3 because the max is 2 for pair 3 comma 2 and max is 3 for 4 comma 2. This means here in theoretical this one mm, theoretically they have given at r equals 2 I must be greater than or equal to 2. When r equals 3 I must be greater than or equal to 3. So this part, just remember this one. So when I must be greater than or equal to 2 when r equals 2, I must be greater than or equal to 3 when r equals 3, when r equals 3, right? So just remember this part, right? So let's move on with the further steps. Let's move on with the further steps, or let's come to the step 3 here, right? So we have to count all the valid intervals. So that's what they have asked in the question. So we have to count all the valid intervals. In simple terms, we need to count the number of subarrays that does not contain both the elements of any 4 pair. So that's what they have asked in the question, right? So let's come to the calculation part. We have everything ready now. We have everything ready now. All we have to do is the calculation, the final step. We have to count all the valid pairs. We are going with a pure this one, what do we call, two pointer sliding window approach, right? Let's make use of the sliding window from left to right. One window will be kept there itself and another window we will be moving in the sliding window, right? If you know the sliding window part. So now let's make use of the sliding window from left to right. Let's make use of the sliding window from left to right. Let's initialize first. Initially let's initialize the result to 0. We need the result variable to store the result, right? Also we need left equals 0 initially, L equals 0, right? So now for each r from 0 to 3, now we will consider for each r from 0 to 3 because we have the values 0 comma 0 comma 2 comma 3. So here again, so the same thing I have written, man, here. See, r equals 0 initially, L equals max of this one will be doing max of left comma block of 0 initially, both this one L left is 0, initially left is 0 and block of 0 the value is 0 itself. So max of 0 comma 0 will be 0. Valid intervals ending at 0, this one from 0 to 3 we are going. So we will be considering 0 1 2 3. We will be considering 0 1 2 3, right? So count will be 0 minus 0, 0 minus 0 plus 1. We'll be going with 0 minus 0 plus 1. Here it would be 1. So the initially the result will be 1. Initially the result will be 1. This is fine. Same we'll do for 1 2 3 calculation. I'll just go with max of 0 comma block of 1. Block of 1, again this one stays same because this is 0 and block of 1, block of everything is 0 itself. So max of 0 comma 0 will remain 0 itself, right? So valid will be 0 comma 1 and 1. Another interval is just but 1. So count will be here 1 minus 0. This one 1 minus 0 plus 1. 1 minus 0 plus 1, the right side one. So this one 1 minus 0. How you will say this one? This is xi yi. Suppose this is x1i. So this one x1. Just give me a second here. Mm, this is not x1i, x1i is not given, and this is y2 I. So we are going with just give me a second here. This is x1I, sorry, this is x1I, and y2I is not given here. So what we are doing here, we are going with x1I minus xi plus this one, y2I minus yi, right? So this one will be 1 minus 0 plus 1, 1 minus 0, uh, 1 minus 0 plus 1. So this will be 2. So this one will be, sorry, 1 plus 2 we will get. How? So yeah, this value, count value, we will get 2. Count value we will get 2. Result is from this one, 1 plus 2, right? So r we have 1, r we have 1, this time r we have 1. So what we will be doing, just give me a second, r we have 1, this will be 1 plus count, 1 plus count here, this will be 2. So 1 plus 2 will be 3. So now let's go with when r equals 2, L equals max of 0 comma block of 0 comma block of 2. So this will be max of 0 comma 2. So this will be max of 0 comma 2. This will be max of 0 comma 2, because now we have the block of 2 value as 2. Now we have the block of 2 value as 2, right? So here block 0 consists of value 0, block 1 consists of value 0. Initially block 1, block 0, block 1, block 2, block 3 all were 0, right? So block 3 will be 2, the maximum we got. So we have already calculated box this one, block 4, we have the value 3, 0023 is the value that we got, right? These two are the maximum. This remains 0 itself for now, right? For now. So this we are calculating when r equals to max of this one, 0 comma 2, max will be 2, and valid of 2 equals count of 2 again. So we will be going with this one, as we are dealing with the intervals. This will be 2, this will be 2 minus 2 plus 1, 2 minus 2 plus 1. So just give me a second here. Did I miss anything here? No, right? uh, this will be, yeah, this will be 2 minus 2 plus 1, similarly to this one. So result, this one will be 3 plus 1. So the count we have got here is 1, and the result, this one, 3, previous one we have to consider here. We have got 3, previous one plus the count we have got here as 1. 3 plus 1 is nothing but 4. Here also we are considering previous one, previous value is 1, and the count we have got 2 here. 1 plus 2 is nothing but 3. That is how we got 3 here, right? So we have got here, just give me a second, 1, and another one is 3, and another one is 4. So I'll just write it over here itself, 1, 3 and 4. We are left with only when r equals 3, when r equals 3, right? So this one will be max of 2 comma block of 3. So here in this case, for this one we are considering 2 value 2, and block of 3 we have 3, block of 3 we have 3, right? Block 1 0, block 2 again I'm telling 0, block 3 maximum we got 2, block 4 maximum we got 3, right? Block of 3 we are considering, block of 3 consists of the maximum value 3, 2 comma 3, max of 2 comma 3 will be 3. So again we will count this one, we'll go with the count. So x1 y1 we considered, that formula will be applying here. This will be 3 minus 3 plus 1, that is nothing but 0 plus 1, it will be 1 itself. Count is 1. Previously we have got the value 4, previously we have got the value 4, that one plus count, previous value plus 1, plus 1, nothing but the count, previous value plus count, nothing but here 4 plus 1, this will give us the value 5. So we have went with for we have went for 0 1 2 3, right? So we have went with 0 1 2 3, right? So we for each r from 0 to 3 we went with. So the value that we got here is, first one for 0, when r equals 0 we have got 1, this one 1 3 4 and 5, 1 3 4 and 5, 1 3 4 and 5. We have to go with the maximum value and we have to return it. So final maximum value that we got here is 5, and we will return uh, this one. We will return the value. We will return the maximum value, nothing but 5 here in this case, right? So the 5 valid intervals here are 1, 1 comma 3, this one, this one, this one. Just give me a second here. 1, 1 comma 3 for 0 comma 1. This one for 0, 1. For 1 it is 3, from 2 it is 2, and from 3 it is 4. You don't have to worry about it. We have went step by step, right? So we don't have to this one worry about this, but we just have to return the total number of this one total number of valid intervals that don't include any 4 pair, right? So these are the total number of these are basically the valid intervals, and we have to return only the total number of valid intervals. We don't have to return the valid intervals, right? We just have to go with the total number of valid intervals. So these are the 5 valid this one intervals x comma 5 that don't include any 4 pair. So this one we need to return here. In this case we got this one, what do we call, total number of valid intervals we got here as 5, which is equivalent to the output that they have given for the that they have given within the example 1, or that they have given for the example 1 within the question. So our approach works absolutely correct. Our approach works absolutely correct in this case. As we are done with the approach part, or as we are completely familiar with the approach, let's move on with the complexities part, right? So let's move on with the complexities part. Just give me a second here. So yeah, so what would be the time complexity here? The time complexity would be big of n plus m. So the time complexity would be big of n plus m, because we will process, we in the input we have n and m. In the input we have the for the example we consider m was this one, what do we call, 4, and n was 2, and n was 2. Sorry, this one, I did I go completely, what do I call that one? So n was 4, m was 2. Yeah. I know. N was 4, m was 2. N is 4 and m is 2. Right. So here in this case, we are processing n exactly once. We are processing n, this one, n equals 4. We are processing n exactly once, and m 4 pairs also exactly once, this one, n 4 pairs. So we have 3 comma 4 and 4 comma uh, 2, I think, right? So what were the 3 comma 2 and 4 comma 2? I think the 4 pairs were, yeah, 3 comma 2 and 2 comma 4 were the 4 pairs basically, right? So I'll just consider here 2 comma 4. This is fine. These are the 4 pairs. We are processing, or we will be processing n once and m 4 pairs once accordingly with the approach. So both are in the linear time. So this will be big of n plus m. So the overall time complexity would be big of n plus m. So what would be the space complexity here? We will be making use of the arrays p, position pos, and the block, right? So each of the size n, each of the size and total space complexity would lead to big of n. So this is the time complexity and this is the space complexity. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n plus m and big of n respectively. Big of n plus m and big of n respectively, right? So I hope the complexities part is completely clear along with the approach. As we are completely familiar with the approach and the complexities part, let's start writing the code. So now let's start writing the code. I'll just come to the compiler here. We'll be making use of the fast input and the fast output, nothing but buffered reader and print writer. So here in this case, let's import java.io.star. So this is fine. And let's do one thing. Let's go with the class here. Class name I'll just give class main. So this is fine. So here let's go with the what do we call, main. So let me delete this one. Let me delete this one entirely. So let me give here throws input output exception as well. Let me go with throws input output exception as well. So here let me go with um, buffered buffered reader br, and let me go with new buffered reader. So this one will be new input stream reader of this one system.n. So system.n inbuilt we are considering, right? So this is fine. And also we'll be going with the print writer. We are just setting up input output here, right? So I'll just go with I have to type. So let me type this one, print writer. So this one, let me consider the variable out, and let me assign this one to the new print writer. So this one will be system.out. So this is fine. So we are done with setting up this one, what do we call, input output. Next, let's move on with the further steps. So the first step is we have to read n and m. Nothing but n is nothing but the length of the permutation, and n is nothing but the number of 4 pairs. We know this one, right? So we have to read that one, right? So let's set this up. So I'll just go with the string here. So s equals br, nothing but the buffered reader. So this will be buffered reader dot read line, and also let me go with split here. Let me go with split here. So this is fine. So let me go with n, and let me assign this one to integer dot parseInt here. Integer dot parseInt. This one will be s of 0. S of 0. This one will be comma m equals integer dot so this one will be percent as it is integer. So this one will be s of 1. This one will be s of 1. So we are going with n and m. N is nothing but the length of permutation. M is nothing but the number of 4 pairs accordingly with the input, right? So this is fine. So now we are done with this part. Next, let's move on with the further steps. So further steps, when I say further steps, so we have to go with the actual permutation, nothing but p. In our case, in the example, we considered 1 3 2 4. If you remember the first input or the first example that we considered, p will be actual permutation. We will be considering position as well, pos, along with the block is nothing but which stores the blocking index. So we have to go with the index. Zero based indexing, we have went with the zero based indexing, right? So we considered p and we block that one to the particular index starting from the 0, as it was zero based indexing. If you remember the approach, exactly what we discussed in the approach, that one we will be articulating in the form of code here. That same thing we will be articulating in the form of code. So now we have the actual permutation, we have the position of each value, in p, nothing but pos, and also block, nothing but it stores the blocking index. Now I can write in this way, and this one p, let me go with new int. So within the array I'll just give n. So pos position, I'll just give your new int, this one n, and the final one is block. I said block, right? So for blocking the index, basically this one will be new int of n. So this is fine. Now let me assign s to we have to read this one. I'll just go with the buffered reader dot read line. So this one will be split, buffered reader read line dot split. So this is fine. This is fine. So next, let's go with the simple for loop or the iteration part. Here this will be int I equals 0, I less than n, and let me go with I plus plus. Within the for loop, what shall we do? Within the for loop, we have to make the 0 based value, because we will be starting from the 0. We have to make 0 based value, and also we have to store the position of each value in the p. So these two things we did in the approach. Same thing, let's articulate in the form of code within the for loop. So this one, to make 0 based value, I'll just go with iterated value of the p. Let me assign this one to, this is integer, right? So this has to be integer every time. This will be integer dot parseInt of this one, s of i, this one s of I, minus 1, entirely minus 1, because we have to go with the integer, this one, we have to go with the zero based indexing. That is why we are going with the minus for 1 for the entire thing, minus 1 for the entire thing, right? I hope this part is completely clear. Don't get confused. Yeah, we are going with a zero based indexing, so we are making zero based value here. That is the reason we are making zero based value here. So next step is we have to store the position of each value in the p, right? So I can write in this way, position of p of I. This one, let me assign this one to the I. So let me come out of this one entirely. We have to process each 4 pair. So I'll just go with while this one, if it is greater than 0, then let me assign s to this one, br dot read line. So this one will be split, br.readline.split. So let me go with a, and let me assign a to, so here this will be integer dot parseInt of s of 0. So this one will be minus 1. So zero based index, and we have to make zero based value again for the b as well. So let me copy this one entirely, just change the variable name from a to b. That's it, right? So let me make this one B. So this remains same. Except one more thing we have to change here. This one will be s of 1 rather than s of 0, right? So this is fine. We are done with this part. We are just processing each 4 pair here. So if you remember in the approach, first we processed 3 comma 2, then we went with 2 comma 4 or 4 comma 2, right? First we processed the first 4 pair, nothing but 3 comma 2, and then we went with the second 4 pair, nothing but 4 comma 2 or 2 comma 4, right? So that is what we are doing here. We are processing each 4 pair. Next we have to get the positions of A and B in the permutation. If you remember the approach, we have to get the positions of A and B in the permutation. So how can we articulate the same thing in the form of code? I'll just come here. So we were assigning that one to the max value that we got. We were assigning that one to the U and V. If you remember, the same thing, nothing but it is in English we say that we have to get the position of A and B in the permutation one. So we'll be articulating the same thing in the form of code. So this one will be int U equals position of A, and one more thing here, let me assign V to position of B, V to position of P. This is fine. So the next step is we have to ensure U is always less than V. If you remember, so the maximum, we got maximum 2 comma 3, but 3 comma 2, but we assigned U to 2 instead of 3. We assigned U to 2 instead of 3 because we have to consider the smallest value for U and we have to consider the largest value for V. So again I'm telling, right? Again I'm telling the same thing. Here we are ensuring U is less than V for range handling purpose. U is less than V for the range handling purpose. So I can just write in this way. If U is greater than V, then what we will do? So I'll just go with the temp variable. Let's consider the temp variable and let me assign this one to the U, and also let me assign U to V, and let me assign V to temp. Let me assign V to temp, right? So let me come out of this one entirely. Let me come out of this if condition entirely. Now what we need to do, uh, we are done with almost all the things. So we are left with certain things. Now we have to update the block of V, right? So now we have to update the block of V. So initially, if you remember the approach, every block 0, block 1, block 2, block 3, every block had the value 0, right? So we had got the value 2 and 3, max 2 and 3, max 2 and 3. So we assigned block 3, this one, block 0, block 1, block 2 to value 2 and block 3 to value 3, right? So initial two blocks were 0 itself, 0 0 2 3. So the same thing we have to do it now. So we have to update the block of V to restrict the valid interval starting points. We have to update the block V to restrict the valid interval starting points. In this case it will be block of V, so let me assign this one to the math.max of this one will be block of V, comma U plus 1, U plus 1. If you remember, we went with U plus 1, right? So if you remember, to calculate the max, right? So we are done with this part. So I'll just come out of this one entirely. Now we are left with only certain things, means we have to go with the result part and also a bit of input output part, right? So output part basically rather than the input part. So first we have to store the result somewhere, means we have to store the total valid intervals. We have to store the total valid intervals somewhere. For that one we will be making use of the result variable. Initially let me assign the result variable to 0, or let me initialize this one to 0. Now we are left with current left boundary of the valid window, means we have to initialize L to 0 accordingly with the approach. So I'll just go with int L equals 0. L equals 0. Let me go with a simple for loop here. This will be for int r equals 0, r less than n, let me increment r here. So within the for loop we have to slide L forward if any four constraints is present at r. So we are performing pure sliding window here. We are just gonna slide L forward if any four constraint at is present at r. right? I can just articulate in the form of code in this way. This will be L equals math dot max of this one. We will be considering L again. So this will be block of R. As I have said, we will be sliding L forward if any fork constraint is present at R. Nothing but we will be considering block of R. So this will be block of R. So this one will be block of R. Next step is we have to count the intervals that is ending at R. We have to count the intervals that is ending at R, means from L to R. So I can write on this way: result equals result plus R minus L plus 1, R minus L plus 1. This is fine. So let me come out of this for loop entirely. We are done with almost everything. We are left with outputting the total number of valid intervals. Nothing but we have to output the result, and we have to uh, this one flush the output. Either for flushing the output you can go with out.flush or out.close. For outputting the result you can just go with println of result, right? So we have to output the result, nothing but we have to output the total number of valid intervals. So this will be out dot println uh, dot, yeah, this one is fine, println of result, because we have to output the result, or we have to output the total number of valid intervals. Next part is we have to flush the output. Either I can go with out.flush or out.close. We were making use of out.flush everywhere. This time I'll just go with out.close just for a change, right? So just for a change I'll be going with out.close. You can go with either of them. You when you are making use of this one, buffered reader and the print writer. Basically print writer, this belongs to the output part, right? So basically when you are making use of the print writer, you can to flush the output, you can just go with out.flush or out.close, anything, right? So this is it for the coding part. So this is it for the coding part. Before checking the code with different inputs, I just want to copy paste the signature starter template. Just give me a second here. So I'm gonna come here. So I'll just paste the signature starter template here. So let's focus on the logical part. So I'll just come to the question here. So let me copy the input here. This one. For this one, we have to get the output 5. For this one, we have to get the output 5. So let me paste this one and let me run this one. So here we have error. So here, see, I have misspelled max here, right? So line number 50. Mm, let me delete n here. So let me run this one again. So we are getting the output 5. So code works absolutely correct, right? So let's try with different another input as well. So I'll just come here. Let me copy this one. So the output that we need to get here is 20. Let's see. I hope this works, man. Let's see. So yeah, we are getting the output 20. We are getting the desired output, right? So our code works absolutely correct. Whatever the code that we have written works absolutely correct for the examples that they have given in the question. So I'll just copy this one entirely. I'll come here. Let's select 4 pairs here. C itself, right? Yeah, problem C. So let me paste the entire code here within the editor. Yeah. So let me submit this one. So I hope this works for all the test cases. Let's see. Let's wait for some time. You can clearly see here running on test one, right? Let's wait for some time. So here you can clearly see in the toast notification, it is showing accepted. Here also it is showing accepted, right? So whatever the code that we have written, works absolutely correct for all the test cases. Absolutely correct for all the test cases. We have successfully solved the interval problems by making use of the two-pointer sliding window approach. So now we are done with the intervals problem. Next two problems, basically, we will be solving. We will be making use of pure greedy approach. We'll be making use of pure greedy approach, right? So these are the three intervals problem that I wanted to solve, basically, right? So uh, we had made use of this one, what do we call a mainly greedy approach, as well as we have made use of, for this particular problem, we have made use of the two pointers or the sliding window, right, to solve the intervals problem. Usually we'll be making use of the greedy approach within the, or to solve the this one intervals based problem. Right now the next two problems will be based on completely this one pure greedy approach, right? So after we are done with this one intervals and greedy problems, as I have said, we are left with only the four this one we will be left with only the four topics. One is bit manipulation and math, and the last three topics are very important. We will be left with this one, what do we call segment tree, fenwick tree, or the sparse table, one topic. And the final two things are extremely important: advanced graph and advanced dynamic programming, right? I hope the solution part is completely clear for this point, this question. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.